Hello, friend. As you probably know, there are 8 planets in our solar system. All of them are different in size, appearance, and represent completely different worlds. Today we are going to visit with you one of them, namely the smallest one. I'm happy to present to you Mercury. Named after the Roman god of commerce, the celestial body also used to have other names. In ancient Greece, locals knew it by the name of Hermes, and the Sumerians called this planet Nabu. We are waiting for a relatively short flight from Earth to Mercury by cosmic standards. The distance between our planets varies in relation to their orbital position and varies from 82 to 217 million kilometers. Mercury is the closest planet in our planetary system to the Sun, so it is most heavily exposed to its rays. The distance from it to the Sun is only 58 million kilometers. The mass of the planet is estimated approximately 20 times less than Earth's, and it is even smaller than some of the satellites of Jupiter and Saturn. That clearly distinguishes it from the other planets. Because of its size and proximity to the star, Mercury is difficult to telescope from our surface. Because of this, it can be found only in the morning, just before sunrise, or in the evening after sunset. Therefore, ancient astronomers believed that at different times of day, they could see 2 different planets. No one knows exactly how the object closest to the Sun was formed. There are several hypotheses about its appearance. The official theory states that Mercury is not a fully formed planet. It is just a solid core devoid of the basic elements for the accumulation of a full mantle and crust, as the other inhabitants of the solar system, and the current appearance it acquired with the help of meteorite attacks, gravitational waves of other planets, and strong solar radiation. Another popular theory is that Mercury once might have been a satellite of its neighbor Venus, but as a consequence of external forces, was lost to it, and retreated on its own journey. But this theory has criticism from the scientific community, and does not correlate with the mathematical models used in his research. There is also a theory that Mercury once had a full-fledged crust, but lost it after a collision with a giant astronomical body in the distant past. Because of the impact of the gravitational waves of the giant Jupiter, the orbit of the first planet is the most elongated of all the planets in the solar system, and it still continues to stretch out gradually. And according to scientists' calculations, in a few million years, it can reach the orbit of Venus. As a consequence, both planets may collide in the distant future. When approaching the planet, we observe how it proudly alone furrows the cosmic expanse. Mercury, like the nearby Venus, has no satellites of its own, which makes both planets stand out from the others in our system. Its rotation around the Sun occurs several times faster than the Earth, so the local day has a duration of 58 whole Earth days, and 15.5 hours, and a full year is only 88 Earth days. As a consequence, one local day lasts more than half a year. Contrary to popular belief, we can find that Mercury has its own highly rarefied atmosphere, which consists of helium. It is formed by solar winds carrying radioisotopes. We enter its upper layers, and can feel air currents similar to Earth's, while brown hues flicker outside the window, as the atmosphere is tinged with local dust. Closer to the surface, our sensors record that the pressure of the local atmosphere is 500 billion times less than that of the air on Earth. Also in its composition we fix a small amount of hydrogen, neon and argon. Due to the strongest impact of sunlight, temperature in the bright part of the planet reaches a catastrophic for humans 430 degrees Celsius, and on the dark half, it drops to minus 170 degrees. Studies have found that despite such strong variations on the surface, under it at a distance of only a few tens of centimeters, the temperature remains stable. It is approximately 80 degrees. If we try to say something to each other on the surface of Mercury, we are unlikely to be able to hear each other, because the rarefied local space has a very small number of particles that are necessary for the propagation of sound, which in turn is their vibration. We are surrounded almost like a vacuum. Wait, do you hear that? Oh, that's the hum of the solar winds and the planet's magnetosphere. Yeah, they're running wild out here. And if we're lucky, if you and I put our ears to the surface, we can distinguish another unusual sound: Mercury shaking. In the interior of the planet, and in the core of the planet, there's still movement. When we're on the surface, you and I feel Mercury's gravity. It's almost 3 times less than Earth's. And if we jump up, we find that we can fly up 1.5 meters. The average density here is almost the same as at home. Even as we approached the planet, we could discern a surface very similar to that of the Moon. It is also dotted with numerous craters, in which we can also visit. They are named after names we know, such as the crater of Cooper, Shakespeare, Boccaccio, or Beethoven. And the largest one is named Rembrandt, and was named after the famous Dutch painter. If we landed in it, we wouldn't even know we were in a crater, because it's as much as 716 kilometers in diameter. But we'll go to see another place even more interesting. On this planet there is the so-called heat plane, stretching for 1,300 kilometers. It is assumed that it was formed as a result of a collision with a large space object. Its name, the plane, has got for a reason, and fully justifies it, as it is one of the hottest points on the entire surface. Because of this, it is impossible for a person to stay here. If we move to any of the poles of the planet, we will see the polar craters, which, according to scientists, may contain water ice. Our sensors record the presence of a magnetosphere that is 100 times weaker than that on Earth, and by checking the ratings we can detect that the geographic and magnetic poles are close to each other. After looking on the surface, we analyze what is hidden in the depths. In the core there is a core of liquid iron, which is about half the volume of the entire planet. According to calculations, the core is enveloped by a mantle and a silicate shell. Based on these data, we can calculate that the crust is about 35 kilometers thick, while the mantle is as much as 600 kilometers thick. In the core itself, the motion of matter is due to the magnetic field. The temperature reaches enormous proportions, and the entire environment is literally melting. So quickly collecting the necessary data, we return to the ship and leave the territory of the planet. And so, being at a distance and in relative safety, we continue our acquaintance with this inhospitable place. Thanks to radar and radio astronomical methods, it was possible to obtain data on various parameters of the first planet. But the best way to study it is to send spacecraft to the celestial body, and during the entire period of research there have been several. The first of them was Mariner 10, which has flown near the planet 3 times, and approaching it to the closest distance of 320 kilometers. The purpose of this expedition was to photograph the surface, and the device has successfully coped with it, sending thousands of images to Earth, providing an overview of almost half of the planet. Later in 2008, the space probe Messenger approached Mercury, which since 2011 has converged with the orbit of the first planet. The data it provided allowed scientists to study the chemical elements and analyze them. Despite all the complexity of studying Mercury, scientists are not leaving our neighbor unattended. And on October 20, 2018, a new research mission, Bepi Colombo, developed in collaboration between the European and Japanese space agencies, was launched. The new initiative is named after the famous Italian mathematician Giuseppe Colombo, who had a hand in the construction of the route of the above-mentioned ship Mariner 10. However, he is better known for having developed the theory of gravitational maneuvering, which is used in spacecraft missions. With the latest research program, the Mercury Planetary Orbiter and the Mercury Magnetospheric Orbiter were sent into orbit around the planet, the purpose of which is to study the chemical composition of the surface of Mercury and its interior, evaluation of the geological history of the planet, and analysis of magnetic fields and their interaction with solar winds. And we'll be watching for further developments. Today we learned some new, interesting facts about the first planet of our solar system, and who knows what discoveries await us in the future. Thank you for exploring the structure of our universe with me.